Here we go with the next bits. Okay, so this one is again just wanting answers between 0 and 2 pi. We have 2 sine x plus 1 equals 0. So again, if it helps, we can say, all right, I'm going to make u sine x. So now I have 2u plus 1 equals 0 minus the 1. 2u equals negative 1. Divide by the 2. So our ugly is negative 1/2. So now we take it back to our equation here. So sine x is negative 1/2. So now we're asking, when is sine negative 1/2 on the unit circle? So this is short sides. These are our pi over 6 angles, but it's not quadrants 1 and 2, it's quadrants 3 and 4, which is the 7 and 11 pi over 6. So x equals 7 pi over 6. And again, technically plus 2 pi k. But here our only answers that stay between 0 and 2 pi are the ones that we found on the unit circle. So the actual answer is those two guys. When you type these on the computer, make sure the comma isn't with the bottom of the denominator, but next to the fraction. It's a very easy typo to make, and it's really frustrating when that's your mistake because WebWork doesn't have a good error check for that. It's just like, no, that made no sense, you're wrong. So that is by far the most frustrating mistake because it's not mathematical. But you go back looking for a math mistake and you won't find it because it's a typo. All right, so 2 more. This one now involves a squared trig function. So what this means is we're going to have even more answers, but they do at least do us the favor of saying just between 0 and 2 pi. Okay, I gotcha. All right, so let's start with, so I'm going to make u sine theta. So this means u squared would be sine squared theta. So I can write my formula here as 2u squared minus 1 equals 0. Add the 1 to both sides. 2u squared equals 1. Divide by 2. So u squared equals 1/2. All right, now we're going to square root both sides. And remember, what do we do when we choose to write the square root? We better remember the plus or minus. So u could equal positive, so just sidebar, square root of 1/2 is square root of 1 over square root of 2, which is 1 over the square root of 2. That may not be super familiar to y'all, but if we rationalize by multiplying by square root of 2 over square root of 2, we get the square root of 2 over 2, which is a lot more familiar. That is on our unit circle. So a little bit of, they use this trick a lot. So when you see a half, like sometimes it's the half on the unit circle, or sometimes it's the square root of that, which is the pi over 4 45-degree angles. All right, so our plus or minus square root of 1/2 is really square root of 2 over 2 or negative square root of 2 over 2. So u squared, we have 2 answers just solving the quadratic. Now we go back to our trig function. This is really asking us, where is sine of theta equal to the positive square root of 2 over 2? Where is sine of theta equal to the negative square root of 2 over 2? So positives are quadrant 1 and 3, negatives are quadrants 1 and 2, negatives are quadrants 3 and 4. Sorry, that whole thing got messed up. The point being, though, when we have the positive and the negative, it's all four angles that share the same reference angle, that reference angle being pi over 4. So all of our over 4's angle is our answer. So we will get pi over 4. 2 over 4 would reduce, so we skip that. So 3 pi over 4. 4 over 4 would reduce, skip that. 5 pi over 4. 6 pi over 4 reduces, so 7 pi over 4 is our last one. And 8 pi over 4 would be 2 pi, so that's the end of the circle. So that right there is the answer we type into WebWork. In radians, because they told us between 0 and 2 pi, not between 0 and 360. In fact, what you're going to see, as annoying as it is we're going to kind of shift and stick with radians like here to the end of math. And when you do it in several classes over and over again, like after a while, your brain just makes that conversion between them a lot more fluidly. You just got to get used to it. Oh, what are they doing now? I would actually pause and ask, is that a typo? But we can still do this. We're just gonna actually use our 2 pi k's. All right, so first off, we have cosecant. That's initial reaction. All right, but I know cosecant is not cosine, it's sine. So this is 1 over sine. To start with that, so 1 over sine theta equals -2. Now I'm going to sneak my over 1 in there. So if 1 over something equals a thing, I can flip both sides or cross multiply and divide if you want. But the point being, I get, after some math, either way you want to do it, sine theta equals -1/2. All right. So short y side is long x side, which is 30 degrees, which is pi over 6. But this is negative, so pi over 6 would be if it was positive 1/2. And then, so that's kind of like where my brain starts on these, is first like just which one are we going for? Pi over 6. So 1, 2, 3, 4, 5. Pi over 6. 7. Pi over 6. 11. Pi over 6. All students take calculus. Sine is positive in all and S, quadrants 1 and 2. Therefore, we want these two guys. But remember that weird thing I pointed out at the beginning, so let's actually take this and do some writing with it. So theta could be 7 pi over 6 plus 2 pi k. Theta could be 11 pi over 6 plus 2 pi k. Now, k can be an integer. So normally when we have these statements and I say, well, what you see is the answer, what I'm really doing is plugging in 0 for k. If I plug in 0, 2 pi times 0 is 0, plus whatever the number, I get whatever the number is. So that's our first two answers, is we're going to use k equals 0. And we get 7 pi over 6 and 11 pi over 6. Now, they said between 0 and 4 pi. So that's once and then again, twice around the circle. So my other two angles are going to be plus 2 pi to my original two angles. So the other two we're going to get here is 7 pi over 6 plus 2 pi and 11 pi over 6 plus 2 pi. So we can do a little math there, but All right, 2 is the same as 12 over 6. So 12 plus 7 is 19 pi over 6. And then 11 plus 12 is 23 pi over 6. So all 4 of those are the answer for this question, just because they tried to throw a sneak at us and be like, oh, we're going to make it 4 pi and see if they notice. It's a dick move. They don't do it very often. And it's the kind of thing I'm going to try real hard to make sure isn't on the test, because I hate it when people do that. I personally would actually rather you guys gave me the K formula, and then if I said, like, give me 6 answers, well, plug in 0, plug in 1, plug in -1, there's 6 answers. Okay, so there's that one. We had to try it now, so we're going to cut it there.